Hey everyone, welcome to my channel. Today we're gonna do something special. We're gonna settle the greatest debate in all of aerodynamics. Lift vs. drag. Which one is truly the greatest? Now, before we get started, make sure you like this video and subscribe so you don't miss any of our awesome videos. Also, for more videos about physics, check out our sister channel. Now let's get started. Okay, so I know what you're thinking. You probably think you know the answer to this question. Come on, it's obvious. Obviously lift is the greatest. Well, maybe not so fast. You see, at its most basic level, lift is simply an aerodynamic force that acts perpendicular to the direction of flow of air over an object. And drag is the aerodynamic force that opposes the motion of an object through the air. But remember, Newton's third law of motion states that for every action there is an equal and opposite reaction. So even though the wing generates lift, which is great, it also creates drag, which isn't great. But what if we could eliminate this drag? What if we had a wing that generated lift but no drag? That would be amazing, right? Well, actually, it's not. It turns out that without drag, nothing would be able to move. You heard that right. Without drag, nothing would be able to move. This is because drag is what allows us to move forward. If you want to move forward, you have to push against something, right? Well, in this case, you're pushing against the air, and that creates drag. So if you want to move forward, you need drag. So now you might be thinking, well, okay, we can't eliminate drag, but what if we could reduce it? Well, it turns out that reducing drag is actually pretty difficult. You see, drag is caused by several factors, including friction, pressure, and turbulence. Reducing one type of drag often comes at the cost of increasing another type of drag. For example, one way to reduce pressure drag is to increase the surface area of an object, which reduces the pressure drag, but it increases the friction drag. So finding the optimal balance of these different types of drag is a very complex and difficult task. In fact, it is so difficult that engineers spend years trying to find the optimal balance of drag forces for things like cars and airplanes. So if reducing drag is so difficult, what about increasing lift? Is that easier? Well, actually, it's not. Increasing lift also comes with its own set of challenges. One of the main challenges is that increasing lift requires increasing the angle of attack of the wing, which increases the drag. So increasing lift and decreasing drag are kind of two sides of the same coin. Now, hopefully you can start to see why this is such a difficult problem to solve. We want to generate as much lift as possible while minimizing the amount of drag. But as we've seen, increasing lift increases drag and decreasing drag decreases lift. So how do we possibly achieve this seemingly impossible task? Well, the solution lies in understanding the underlying physics of lift and drag and using that knowledge to design the perfect wing. But wait, didn't we already talk about that? Yes, we did. We talked about lift and drag, but we never really got into the nitty-gritty of the underlying physics. And that is where we need to go if we want to understand how to manipulate lift and drag. So let's take a closer look at the physics of lift and drag. Okay, so when an object moves through air, it disturbs the air molecules, and those air molecules exert a force on the object. This force is called drag. The faster the object moves, the more air molecules it disturbs, and the greater the drag force becomes. But that's not the whole story. There's another force at play here, and it's called lift. Lift is the force that opposes drag, and it's caused by the difference in pressure between the upper and lower surfaces of an object. When an object moves through air, it creates a low pressure area above it and a high pressure area below it. This difference in pressure creates a force that lifts the object up. The faster the object moves, the greater the pressure difference, and the greater the lift force becomes. So we have drag and lift, and they're basically the sides of the same coin. The faster you want to go, the more drag you have, and the more lift you need. The faster you want to go, the more lift you have, and the more drag you need. But there's a way to manipulate these forces and potentially have your cake and eat it too. Let's take a closer look at how these forces work together to determine how an object moves through the air. As an object moves through the air, it displaces air molecules. This displacement creates a pressure wave that travels away from the object. This pressure wave has a certain amount of energy associated with it, and that energy is carried by the air molecules. As the air molecules collide with the object, they transfer some of their energy to the object in the form of kinetic energy. This is the drag force. So the faster the object moves, the more energy is transferred to the object, and the greater the drag force becomes. But there's another interesting thing happening here. As the object moves through the air, it is also creating a low-pressure area in front of it and a high-pressure area behind it. This pressure difference creates a force that pushes the object forward. This is the lift force. So the faster the object moves, the greater the pressure difference, and the greater the lift force becomes. So we have drag and lift, and they're basically the sides of the same coin. The faster you want to go, the more drag you have, and the more lift you need. The faster you want to go, the more lift you have, and the more drag you need. But there's a way to manipulate these forces and potentially have your cake and eat it too. Let's take a closer look at how these forces work together to determine how an object moves through the air. Okay, so we've established that drag and lift are basically two sides of the same coin. But what if we could manipulate these forces in such a way that the drag force was always opposed by the lift force? What if we could essentially cancel out the drag force with the lift force? Well, it turns out that we can do just that. It's called the Magnus effect, and it's the same principle that's used in baseballs, golf balls, and even airplanes. When a spinning object moves through the air, it creates two different pressure fields, one on either side of the object. These pressure fields are not symmetrical, and the result is a net force that causes the object to curve. The direction of the curve depends on the direction of the spin of the object. If the object is spinning clockwise, then the net force will cause it to curve to the left. If the object is spinning counterclockwise, then the net force will cause it to curve to the right. Now, how does this relate to our ultimate goal of achieving maximum lift with minimum drag? Well, it turns out that by manipulating the spin of an object, we can control the amount of lift and drag that it experiences. By spinning an object in such a way that the two pressure fields are perfectly balanced, we can effectively cancel out the drag force, allowing the object to move forward with maximum lift. But wait, you might be thinking, doesn't this just create more lift? Well, yes, it does. But remember, more lift means more drag. And by canceling out the drag force, we're essentially getting more lift for free. But wait, there's more. By manipulating the spin of the object, we can also control the amount of turbulence that it experiences. And turbulence is a major source of drag. By reducing the amount of turbulence, we can further reduce the amount of drag. So not only does this technique allow us to generate more lift with less drag, but it also reduces the amount of turbulence, which is a major source of drag. So now you might be thinking, well, that sounds great, but how exactly do I apply this in the real world? Well, it turns out that this technique has already been applied in the real world, and it's being used in everything from airplanes to baseballs. By manipulating the spin of an object, engineers and athletes alike are able to control the amount of lift and drag that it experiences. For example, in the case of airplanes, by manipulating the spin of the wings, engineers are able to control the amount of lift that the wings generate. This allows the airplane to fly at higher speeds while carrying heavier loads. In the case of baseballs, pitchers use their spin to control the amount of movement that the ball will experience once it is in the air. This allows them to throw pitches that curve, break, and even move in unpredictable ways. And that's the story of how lift and drag, two seemingly opposing forces, are brought together to create everything from flight to movement of a baseball. Okay, So we've learned that lift and drag are basically two sides of the same coin. We also learned that by manipulating these forces, we can potentially have our cake and eat it too. But which one is truly the greatest? Well, that's for you to decide. But hopefully this video has given you a new perspective on these two fundamental concepts. Thanks for watching. See you next time.